You could do it now?
Yeah, I'm recording
Okay,
and I can share my screen. Perfect.
awesome.
Okay, so the slides that I set up are very similar to the slides for the vacuum samples and for the grass samples that we were looking at. So I just kept a lot of the intro stuff the same, just as sort of a like an overview. So I'm just going to, sort of just skip over all of this stuff, which is just the basics of how a salt marsh is made and the species in a salt marsh, and tides, where the marsh is, what's going to happen to the marsh with sea level rise, the kinds of critters that are found in the two different kinds of grasses. So Spartina alterniflora has mainly marine species. Spartina patens is mostly terrestrial species. And the sticky traps are going to capture the flying insects in the high marsh that's in the Spartina patens. The shallow pitfall traps are going to capture all of the species that are found underneath the thatch of these two different types of grasses. And I'll go into more detail about how we sampled for them, what they actually did, that kind of thing, in a minute. But the nice thing about the shallow pitfall traps is that they capture things from the alterniflora throughout the patens at every single plot. We put them at all of the plots this past summer. And to an extent the summer before that. This is the first time I think that we've done all of plots, or we might have done it all last minute. I can't remember. But anyway, here's the same deal, all of the sites that we've sampled over time. And the things that we're focusing on are the pitfall traps for large and small invertebrates and sticky trap terrestrial arthropod samples. The thing, actually, let me go back. The thing that I will mention is that all of the sticky traps, they were only placed at the Q5s. So they weren't placed at all of the plots. They were only placed at the very back of the plots towards the upland border in the cases where the upland border exists. Like, for example, this is Patmos South, and they're up against that upland border edge. This is Nelson, and you can tell that it's in the middle of the marsh. This was just that, 150 meters or 120 meters back from the creek edge. So just here at the Q5s, that's where the sticky traps are. Okay, so again, just as a refresher, these are the sites that we sampled in 2019, and then in 2020, we only sampled at these sites. We didn't sample at the two boat sites. So this is what the sticky traps look like. So I tried every year to make it consistent that we use the same exact sticky traps that we used in years past. And it's increasingly getting difficult because the sticky traps, this model of sticky trap is, I think, not really manufactured anymore. It's getting harder and harder to find them. A couple of years ago, I was able to find them on eBay, and then last year, miraculously, I was able to find them somewhere, like some supply. Maybe I can't remember if it was Amazon or where, but I was able to find them. So hopefully, again this year, we'll be able to purchase them because it's good to keep the consistency of the sampling regime. If we need to change them, there are other Victor fly traps that are hanging, just not this like lantern style. So the way that we did it, so there's a picture I'm going to put here on this side. I don't have it with me. It's saved on a hard drive in another, in my apartment. I'm at Nadia's house right now. So I'm going to show the picture of how the sticky trap looks, when it's actually all set up. But essentially, we take one of these sticky traps out of this pack and we hang it up on a string, on a fishing line that's strung between two long bamboo shoots. And so it's sort of just like we stick the two bamboo shoots in the ground with the line in between, like a clothesline, and then we just hang this on top of it. We also sort of like wrap and tape the hook on it because these guys are prone to fall off if it's really windy, which is obviously counterproductive to what we're trying to do, which is to attract all of the things that are flying around above the marsh, but close to the upland border, as I mentioned. Wendy, before I go on to the shallow pitfall traps, do you have any questions about the sticky traps?
Is there like a height you keep it at, or the bamboo like sticks that you put in are what you measure the height by, like how high it hangs
Yeah, good
above the grass?
question. Yeah, good question. So basically, we try to make it where it's, you know, 1.5 to 2 meters above. The primary goal is that we want it tall enough to be higher than the highest grass that's present. So like if it's in the upland border in a patch of alterniflora, we want it to be taller than the tallest blade of alterniflora because it can get stuck on the alterniflora if the blades are moving around in the wind. But generally speaking, you know, two meters, 6 feet above the ground. Actually, that's pretty high. Yeah, we usually do it about uh, 1.5 meters. So yeah, like around four-ish feet above the ground, 4.5 feet above the ground. We put it, and that's good to collect all of the bugs.
Perfect.
Cool. Okay, so the shallow pitfall sampling, again, I have all of those pictures saved on the other hard drive. So I don't have that here. I'm going to include it. But essentially, you know, I'll describe it here so that way you sort of have it. You can, when I put it on this slide, you can just go back to this recording and then, you know, listen to that while looking at the images that I'm going to post. So essentially the way that we collect using shallow pitfall sampling is that we dig a core into the ground just outside of the plot on the, if you're facing the creek, the back part of the plot on the right-hand side, I believe.
Okay.
And so I get the shallow and the deep mixed up sometimes where, no, I take that back. So it's if you're standing towards the creek, it's the back of the plot on the left-hand side of the plot because the right-hand side of the plot is the deep pitfall trap, which is diagonal to the bite map. So yeah, so it's the back left corner. And so we dig that hole. And then what we did in 2019, one of my RU students, Abby Quiet, she developed this really cool shallow pitfall sampling device where you have your jar of kill juice, which the kill juice has ethanol, sugar, and soap. And the reason why it's ethanol, sugar, and soap is because the sugar attracts the bugs. And then when the bugs get into the jar, the soap reduces the tensile strength of the top of the water, so they just sink to the bottom rather than being able to walk on it like spiders do. And then the ethanol kills them. So it's a potent cocktail of kill juice. So that's in the jar, and the jar is fitted into a piece of foam mat that we cut out, and you'll see a picture of that, a foam mat that we cut out into a rectangle. The jar is in the middle, and there's 2 holes on either side. We put 2 more bamboo sticks that are pushed into the ground on either side of the core, and then we fit the foam mat on over the sticks all the way down, so that way it reaches the bottom of right where the ground is. And the reason why we did this is because we were coming up with these roadblocks in sampling this way, because the tide would come in and it would flood all of these shallow pitfall traps, and then it would either get rid of the kill juice, it would get rid of the bugs, or both. And so it was completely ruining our samples, and we, you know, really had no way of determining whether or not we had an accurate representation of what we were measuring. The way that we did it in the past is that we would only put them at the Q5s, the furthest away from the creek. But on high tides overnight, they would flood. And so this was a solution to that, because when you have the cup of kill juice in this foam mat, the foam mat rises because it's buoyant. It rises along the track of the bamboo sticks as the tide comes up. And then as the tide comes back down again, the track goes back down, back into the hole where the cup fits. and back to where it's basically supposed to be. And so all the bugs, what they do is they still are able to crawl over the foam mat into the cup, and still we have an accurate sample. The other thing I didn't mention is that over the cup we fitted um, a funnel, like that, just any like a plastic funnel, as sort of like a hat for each cup, so that way it would also keep out extreme rain events. So if there's like a little bit of drizzle, that's fine, but if there's, you know, a thunderstorm that comes by, that also could flood the shallow pitfall traps. So the nice thing about doing it this way is that we're now able to do it across all plots, and so we're able to capture all of the critters that are found within the thatch on the quote unquote forest floor of the salt marsh. And so that means we're able to use this in lieu of the the suction sampling that we did previously, which, you know, it is an extremely accurate representation of the population of bugs that are present. But it's, in a way, it's too much. We don't need that much sample to really determine, you know, the representation of insects at a particular patch of grasses to know what species are where at any given time. The other thing that I'll mention before moving on is that these shallow pitfall traps, they were deployed for the length of time that we sampled at any given site. So we sample for 5 days. And so they were deployed typically on a Monday, and then they were taken up on a Friday. So all of that time, there was time enough for the insects to come in and small invertebrates to come in and to capture. And that was standardized across all sites. Okay, so before going into how to process these things, do you have any questions, Wendy?
Do you do like deep pitfall sampling? I only know that for like more so crab species that you do that for, but
We do. So we also do deep pitfall trap sampling to capture the instantaneous day-by-day picture of what particularly marine invertebrates are found. We don't, for the deep pitfalls, we don't sample for any of the insects. Sometimes spiders will get into the deep pitfalls, and we just, you know, shoo them away, and we don't even pay attention to them. But what we're really looking for in those traps are like marine snails, the air-breathing snails, like the coffee bean snail, that is, amphipods. Sometimes you'll get the occasional European green crab. One time we got a fiddler crab, which was very exciting. So yeah, we do the deep pitfalls, and those are also now across all plots.
what are we going to talk about those or?
Well, those we just sample. We basically, the way that we sample for them is that we go out that day, and then we pull up the deep pitfall, and then we by eye determine what's in there, the marine stuff that's in there, and we just count the number of individuals of each species, and then record which species are present.
Okay.
And so we don't have any, you know, long-term samples. We just, you know, clean it out at every day that we sample, and then we put it back in anew.
Do you just use a tennis ball canister?
That's what we
use?
had used in the past, but then we have also, in current years, we've used solo cups that are cut at the bottom. The tennis ball canisters are definitely the gold standard. The only problem is that they are kind of pricey, and we don't have any anymore. But they are really good. That's maybe something to consider for sampling moving forward, is to start using those tennis ball canisters. The only problem is, of course, that if you're trying to determine long-term data, now that I think about it, you know, using a different sampling scheme might confound things. But
yeah, it'd have to be like reusable year to year.
Right.
But I don't remember. I feel like Jen got hers from like, she just like asked the tennis club for donations or something. Like maybe we can just pair with something to like make sure we have them every year rather than like spending the money on them. But
Yeah. Yeah,
I hear,
I would imagine that there's a bunch of tennis clubs in the Newburyport area.
yeah, that we could just ask.
That's a good point. That's a good idea. Um, so yeah, maybe this year what we can do is we can do both. We can do um, like the uh, tennis ball canister as well as the solo cup, and then we could compare the two. And if there's really no major difference between the two from all years on out, we could just use the tennis ball canisters.
Yeah, as long as we have like a viable place to get them from each year.
Yeah, exactly.
Okay.
Yeah. Cool. Awesome. All right, I'm going to move on to the sort of, how we sample for these things now that we have them. So we want to determine the abundance and species composition of each organism down to the lowest taxonomic level possible. Some of them we're going to very easily be able to determine like species, genus and species. Some we'll only be able to do by family. So for sticky traps, you're going to observe the whole trap with your naked eye and with a dissecting microscope. And so for the shallow pitfall traps, it's basically emptying the sample into a gridded sampling plate, shaking the plate slightly to make the sample uniform across the plate, and then determine the abundance and species composition for all insects for both stickies and shallows. I can probably get rid of the stickies that are here because I already said it before. But essentially, unlike the vacuum samples, which like I said, we had so much stuff that we got from them that we actually ended up needed to doing some subsampling from there. We're not going to get nearly the same volume of critters in either the stickies or the shallows. And so we want to enumerate all of the different species that are present. So so this is blank for a reason. I'm going to either today or tomorrow put together a data sheet, a sampling data sheet that I'll link here. It'll be a Google sheet. And then this here is a link to the bug guide that will allow you and all of the undergrads to identify all of the bugs that are present. Particularly for the stickies and for the shallows, I don't think that you will ever encounter a species that is not already identified in the bug guide. This bug guide is pretty comprehensive and has been created from the vacuum samples. It's really the vacuum samples that will collect things that are rarer species that are less likely to be typically found. But if there is an instance where you really don't think that the species that you're looking at or the individual that you're looking at is represented in the bug guide that we do have a protocol for identifying unidentified bugs. So I'll go into that as well. Okay, so this is the bug guide, and here's the link to it again. So I can even pull it up right now. And it's like I said, a very extensive guide. It's got around 100 slides of both terrestrial and marine invertebrates, primarily terrestrial, because this is based on the vacuum samples, as I mentioned. Some of the marine species that are going to be found may not necessarily be included here, but they're pretty easy to identify. I mean, it's primarily going to be amphipods. I mean, there's just a shit ton of amphipods, which you can quote me on, which I realize I'm now being recorded. So there's just a lot of amphipods.
Edits video later.
Yeah. And so what was I saying? Oh yeah, so there's a lot of amphipods, and there's going to be a lot of these coffee bean snails probably that have fallen in. There's not going to be so much Litorina litorea, and you may find some baby green crabs. You're not going to find Sesarma reticulatum because this is a species that is found south of Cape Cod, but not north of Cape Cod. yet. So it has not expanded its range as of yet. And God help us if it does, because it is a voracious herbivore that is known to have some impact on marsh die-off at the creek edge due to predation, or herbivory, I should say.
Do they have them on Nantucket?
They do have them in Nantucket. They're very abundant on Nantucket. So, yeah, I highly recommend going to Nantucket at some point and checking out that system and seeing the purple marsh crab, because they are a really cool species, but they're pretty nasty, pretty mean guys. So in any case, this is that bug guide.
Okay.
This is the un-ID'd bugs. So there's a list for that. And so if you come across something that is unclear, you can look at the un-ID'd bugs and see if it matches. And maybe you have was used to be unidentified is identified now, or is still unidentified and can go in that category. There's the protocol I included at the very last slide, which I'll go into at the end. But I think that, like I said, that's pretty unlikely at this point that you'll need to use that.
So once we go through a sample, do we throw it out, or do we like put it in tinfoil, or?
Great question. So
is
that's
it counts? Is it weights? Like.
Yeah, so that's a great question and a great segue to the next two slides, which are the step-by-step guide for doing the sticky traps and the shallow pitfalls. Okay. So for each sticky, take a box of 2 sticky traps, open the flap and look inside. So each box that I showed you before has 2 stickies in it. And so you want to, before even pulling them out, you want to look inside. So when you open it up, there's going to be sort of the flaps on either side that hold everything in. What we did was we labeled the site, the year, and the plot on the top of the sticky trap as well as on that flap. So you want to make sure that the flap and the sticky trap match. And so as you see, the inner flap should be labeled. Pay close attention to that label. It should match the label on the top of the sticky trap if the top is still there. There's going to be 1 or 2 where the top is falling apart. And so that's why we did it that way, to keep things consistent and to make sure the labels were clear. So before even taking out the sample, record on the data sheet which sample you're processing. Then very carefully remove the sticky trap that you just recorded from the box. You may need to take both out at the same time, but put the trap you are not working on back in the box to be processed later. And the reason for that is because the 2 traps are like really close together and both are sticky. And so you might scrape off some of the insects on one or the other that you're trying to pull out. So you may need to pull both out, separate them, and put one back in. So then after you've pulled out your trap and you're ready to look at it, you want to identify each insect species down to the lowest taxonomic level and record the number of those individuals total per trap. So for the whole trap, you're just counting the number of, let's say there's a particular fly species that's present. You want to count all of the individuals of that fly. And then let's say there's another fly species and individuals of all that fly, and so on and so forth. If you encounter a bug not on the data sheet, follow the guide for unknown bugs, which is the last slide, like I mentioned. Record the data, recording data in the data sheet is easy. Just make sure to include all the data that is asking of you at the top. Do not leave anything out. And the reason why this is important, particularly for the undergrads that are sampling, is that there is a lot of redundancy to the way that we sample. So that way, in case one thing is missing, we still have everything accounted for, which I'm sure you're well aware of and well versed in, Wendy, from all of the sampling that you've done out west. So this is really more for folks that haven't done this as much. When finished, set that sticky trap aside and pull out the other trap from the box to process. Make sure to record all the same information, including the sample label on the top of the trap. And then once both are finished, then put them both back into the box at the same time, and then set that aside and move on to another box. Short term, in terms of short-term preservation, they can stay out of like the freezer or refrigerator for a couple of days, for like a day or two. But beyond that, then they start to rot and they start to become really gross. So putting them into a fridge is better, is the best way of doing it. Leaving them outside also works if it's cold enough. But processing these should go relatively quickly, and then from there, it's just bringing them back to campus and storing them back in the freezer. So that's the other thing. These are also stored in the freezer, not in the cold room, because within the freezer they tend to start rotting and get moldy. So for the sticky traps, we are keeping them long term for now. We have all of the sticky traps that we've sampled since 2017. I think the ones from 2016 and earlier, I ended up throwing out. I can't remember now at this point, but we may need to start throwing samples out, as we
Pretty packed in those refrigerators
yeah,
or freezers.
exactly. Yeah. Okay, so for the shallow pitfall traps, so you're going to grab a jar that you are sure has a 2020 label on it. There are going to be some jars that look very similar that say 2019 on them, so just be careful of that. The jar should be labeled on the outside, but it also has a paper tag on the inside of the jar, and those two tags should match, the one on the outside and the inside. So then you're going to grab a gridded dish. The reason why we're using a gridded dish is because it's a really like that area is a really great way of determining like the species that are present. We're not actually using the grids for anything. I'll also include here that you can use like a watch glass, like a deep watch glass. That's another way to do it. So basically you can use either one, whichever one you feel most comfortable with. So leave the jar next to the plate. Gently swirl the plate or the watch glass around to make the sample uniform across the plate to make it easier to see. And then you want to identify each insect species down to the lowest taxonomic level again, and record the number of those individuals for the whole sample. We're not subsampling here because there's not going to be a lot of stuff by and large. There's going to be some samples that are just like, again, a ton of amphipods. Again, there's a protocol for unknown bugs, and then the same thing for recording stuff in the data sheet. Please do not stop working on a sample halfway and come back to finish the next day. We did that to an extent with the vacuum samples because it took a while to process them. These are not going to take that long, and it also gets really confusing when you do it for these particular samples. So if you start a sample, finish that sample that day, and if you think that you're not going to have time to finish a particular sample, set that aside. Don't start it unless if you know that you can finish it. If an emergency comes up, that's a different story, but this is a general rule of thumb. Once you have identified all the bugs, put the sample back in the jar it came in, and you want to put a new label using Write in the Rain paper. And I'll describe to you, Wendy, where the Write in the Rain paper is to distribute to folks. And basically tearing off a small piece, using that as a label. And you want to write on it the word processed, your name, and the date. And so that way we know that it's been processed, it's good to go, and the date and the person who processed it. So cap the jar, set it aside to be returned to the ISC, and begin a new sample if time allows. So before going into an unidentified insect or invertebrate, Wendy, do you have any questions about these two protocols?
Not right now.
Okay, very good. All right, so this is the unidentified protocol. Mark wrote it up. Congratulations, you found a new bug. Here's what you should do next. So you want to take good pictures of the bug using your phone and scope. No light or just AmScope light is best, or the distal scope. Take at least one dorsal and one ventral pick, lateral pick 2 if possible. Put bug by itself for this pick. Place bug in vial, centrifuge tube, and number it. Use the consecutive number unknown and then the number. And then there's within the data sheet that I'm going to be giving, there's going to be a list for unidentified bugs. Name your new bug based on its order, color, size, pattern, etc. Red bug is not a good name, but red-eyed tiny diptera is okay. And this name, add this name to validation. So there'll be a validation tab as well on the data sheet. Record all this info on the sheet on the wall. In this case, you don't need to do that because we're not on campus. Upload your pictures to the unID'd Marsh insects and spiders slideshow in the Google Drive, which is this guy, this one. Include the number and the name of the species. And then this is later to identify, this is less important. This is for primarily, this will be something for you to do as unidentified bugs come up to try to identify them in the future. So that's basically it. It's more or less straightforward. It's just taking the sampling device, taking the sticky trap out, uncapping the jar, and just identifying what species are there and how many of them. That's it.
Okay. Going back to the unidentified bug thing, when I go back on campus, or Michael, should we be writing it on that list for when we do come back to campus?
Nah,
does that need to?
No, that's fine. This is for the vacuum samples, and I'm gonna make sort of an executive decision and say not to worry about this list, because at the end of the day, the most important list is the Google sheet. I mean, that's the one that's more of a complete record. And I think that one is a more robust way of saving the data. So.
Okay. That sounds pretty easy. The other question I have, going back to the shell pitfall traps, you know how it's like a really big thing to put like copper rings in the intertidal so that like you won't get certain species in a trap. Do you have that with like the foam traps? Like, do any insects not like that, like feeling of foam or something? They don't cross over that barrier into the shallow pitfalls?
Great question. I have no idea. Yeah, it's a great question. It was something that, we toyed with back and forth, and it ended up being where, the likelihood of that happening is possible, but that by and large, we were sort of making the assumption that the cost outweighed the benefit of being able to sample this way.
Yeah.
We haven't, to my knowledge, I mean, I haven't done this, maybe Jared has, but we have proportions of individuals of each species per plot for different sampling methodologies. So one thing that we could do is we could compare the insect populations that we determined from the vacuum samples versus the shallow pitfall trap samples. And we could determine whether or not we are missing anything. And that would actually be a good exercise to do, because then we would know whether or not the vacuum sampling was a better methodology. So we'll see.
Okay.
But I'm gonna stop recording. Now.